So we want to look at our normal distributions, converting them to probabilities, which is on page 19 of your book. So we're interested in what is our normal distribution. We all recognise our normal distribution. Hopefully we all recognise that when I colour in the area underneath that curve, that area is going to be equal to 1. And the reason for that is if we think back to what our probabilities are, our probabilities all must be between 0 and 1. And all probabilities have to add to 1, so that our area represents the probability. So if I want to know a particular section of that area, I'm going to have a smaller probability. If I want to know the whole area, that gives us a probability of 1. Let's look now again at that distribution, and let's look from the mean. So if I was to draw a mirror image down that line there, down your mean, we know that the left-hand side and the right-hand side should be symmetric. So if the whole probability area has to add up to 1, 1 is the same as 100%. So that means on the right-hand side, above the mean, the total area above the mean is going to add up to 50%. Equally, if we look at the area on the left-hand side, so the area below the mean, that's also going to be 50%. Okay, so half of the data is above the mean, half of the data is below the mean because of the symmetric nature of the normal distribution. If we now look over the page, so onto page 20, you'll see this diagram of the normal distribution. When we look at this distribution table, this is the table you'll be given for your assessment in the exam. We will look at how to use it, we'll learn how to use it, and then we'll go on to looking at how we can get the calculator, the graphics calculator, to do these calculations for us. So if we start one bit at a time, first of all let's start by looking at the graph itself. So at the top of the table it's going to give us this graph, and that graph has a black area shaded in. The area that's shaded in represents the probability that we're trying to find. We've also been given the formula for z. As you can see, z equals x minus mu over sigma, so that's always going to be stated there to remind us if we need it. On the table itself there are the grey areas, and any grey area that there are represents the probabilities. So all those numbers in there are going to represent the probabilities. Then if we look at the numbers on the outside of the table, these orange areas that I've coloured in, those orange areas represents your z value. So if we think back to the previous example, we had z values of negative 2.5, which represented 2.5 standard deviations below the mean, and we can look up what these probabilities connect to now. So let's have a look at the example. So what we've got here on this part, we've got a couple of examples. We'll start with the one on the top. And they've started off by giving us a z value. And so what we want to do is we want to take that z value and we want to find the probability. So the first thing that we do is we look at the very first decimal place. And so we've got a value of 0.4. So we're going to go to our table, and on the left-hand side, we look down till z equals 0.4, and as you can see I've highlighted that row of numbers that connect with that. Now I'm going to look at the second decimal place, and the second decimal place number is a 5. So now I'm going to look at the second decimal place there of 5, and you can see I've highlighted that column 5. So those numbers across the top are our second decimal place. And that's giving me a probability of 0.1736. So that's one of the things that I need to write down to start with. Then I need to look at my third decimal place number, and you can see on the right hand side of the table is these columns with the words differences written in, and that's looking at what that third decimal place is. So in our case our third decimal place is 6, so we're going to look at that column with 6, and we're going to add that value of 22. Now that value of 22 is actually 22 times 10 to the minus 2. So it's actually the equivalent to 0.0022. It's looking at the difference from the value of 0.1736. And it's the last two decimal places there match, so it's 2 decimal places. So that's going to connect to the probability at the top. And so I'm going to add those two probabilities together. The probability is 0.45, and add that difference of 0.0022 on, and that's going to give us our solution of 0.1758.